Speaking of something that just popped in my mind, you know Explorer 1? Let's see if I can search it up. The farthest we sent something out, it's finally stopped being able to communicate with us, sadly. Or, like... No. It's called Explorer, or is it Voyager? Voyager! Why am I? Yeah. This is it. Sorry. I don't care. Unexpected issue in Voyager. Why did I say Explorer? Voyager 1! I know this is... We're jumping off the... what we were talking about before, but it just... Since it jumped in my mind... Voyager 1 has never sees these signals at a steady radio signal to the ground control to operators on Earth. But that signal has not carried any usable data since November. Instead, NASA said, the probe's telemetry modulation unit began sending nonsensical repeating patterns of code. The space agency traced the source of the communication breakdown to one of the spacecraft's 3 onboard computers, known as the Flight Data Subsystem, which is responsible for packing the science and engineering data before it's beamed to the Earth. In order to figure out what's going on, the mission sent a poke March 1st, commanding Voyager 1's flight data subsystem to run different sequences in case software corruption was the cause of the issue. Within 2 days, NASA got this response which it hoped. On March 3rd, the Voyager mission team noticed that activity from one section of the flight data subsystem was different from the rest of the computer's unreadable data stream. Because it still wasn't using the format used by Voyager 1 when it's properly sending data, the team was confused. The array of giant radio network antennas known as the Deep Space Network that communicates with both Voyager probes decoded the signal and found that it contained a readout of the subsystem's entire memory, its coding, as well as the science and engineering data it collected. The discovered readout provided an opportunity for the team to analyze it for discrepancies in the code that could have caused the ongoing issue. Using that information to devise a potential solution and attempt to put into action will take time. In other words, we finally got a response. Now we just have to kind of fix it. Voyager 2 also recently lost contact. Oh, this was back in July. Communication breakdown with the mission control when its antenna is inadvertently pointed in the wrong direction. Contact was lost July 21st with Voyager 2 after mission control transmitting routine data that inadvertently triggered a 2-degree change in the craft's antenna orientation and disrupted the Deep Space probe's ability to receive commands or transmit data back to Earth. Fortunately, the contact was restored in August when NASA's Jet Propulsion Lab sent an interstellar shout. They successfully commanded the craft, which is now 12.6 billion miles away, to reorientate itself. We were shouting at it. Oh no. All right. On to, we finally opened the space thing when we collided with an asteroid to stick a probe into it and get stuff off of it, and then it was stuck inside the capsule for a while because we couldn't get it open. But now we've actually had a breakthrough on this. NASA's new asteroid sample is already rewriting solar system history. Scientists have scarcely begun studying the pristine material from the asteroid Bennu, brought back to Earth by the OSIRIS-REx mission, but have already found several surprises. Meteorites are messengers from the depth of primordial time, cast off fragments of asteroids and comets that form alongside our sun from raw materials predating the stars our star itself. but their messages are often muddled by their final fateful encounter with the Earth, charred in their fiery plunge through our planet's atmosphere and contaminated by our world's ever-shifting environmental turmoil. And unlike a typical piece of lost mail, they don't come with a return address to reveal their provenance. But what if scientists wishing to be historians of our solar system's earliest days could sidestep these problems? Rather than relying solely on random scattered chapters of cosmic history from meteorites, would it be better to directly visit space's most ancient archives, asteroids and comets, to bring back entire geological books to read? NASA's Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explore. You were trying to get Osiris in there somehow, weren't you? Just by that name. By the way, if you're wondering what who Osiris is, it's an Egyptian god. He is very much an Egyptian god. You know, since I have a lot of, cats that are currently named after, Egyptian things. Osiris is the god of fertility, agriculture, afterlife, the death, resurrection, life, vegetation. If I remember correctly, the story of embodiment of the dead and resurrected king, I think his brother killed him and cut him to pieces. I think that's the story of it. I'm not right offhand remembering. And his wife put him back together. And one of the cruel things, as a kind of fuck you, when his brother, cut him to pieces, cut off his penis, and threw it and was eaten by a crocodile, because he specifically cut that piece off of him. So anyways, they worked really hard to get Osiris in here. By that name, Origin Spectral Interpretation. Okay. Did just that in 2020 when it dove down to the surface of the near-Earth asteroid Bennu and retrieved some rocks dating back 4.5 billion years before bringing it back to Earth last September in a dramatic fashion because we couldn't get to it for months. It's not the first or second spacecraft to burgle from an asteroid. Is it stealing if it does? We'll just go with that. But it retrieved a large sample to date, a whopping 121.6 grams of pristine material from the solar system's dawn. Almost immediately after the sample returned capsulated land on Earth, scientists began their forensic examination. And earlier this month, at the Lunar Planetary Science Conference in Woodlands, Texas, they presented their first in-depth findings for all the world to see. The analyses are preliminary, but it seems that Bennu's original form was shockingly familiar across the vast gulf of eons. Billions of years ago, Bennu was apparently part of a water-soaked world, now long lost and otherwise forgotten. One with a beating geologic heart and an abundance of prebiotic organic material. In many respects, this nameless world could have been born a passing resemblance to the early lifeless Earth. Bennu literally carries the building blocks of life within its minerals, says Louisa Preston, an astrobiologist at the University College London. Firmer conclusions are still to come, but it's already clear that these precious pieces of Bennu harbor immense potential. What we're trying to do with these samples is understand how Earth was formed, not just its water, not just its prebiotic components, but how Earth itself formed, said Harold Connolly, a geologist at Rowan University and mission sample scientist on Osiris REX. And it's not all about our blue-green marble. Some of the samples' microscopic grains revealed that Bennu's odyssey began before the sun first fires burned, meaning that planetary scientists can use it as a toehold on their ascent towards the answering one of their field's most enduring and monumental inquiries. What was the starting mineralogy of the solar system? Where did that dust come from? Did it all come from just one star, or multiple generations of stars, or different types of stars? Said Ashley King, a meteorologist from the London's Natural History Museum. Thanks to our mission's daring raid on Benu's ancient ark. You're not fucking thieves! I mean, you're trying to make it sound cool. You're not thieves. The origins of the full name refers to the Genesis in history as a proxy. I read aloud what the Osiris is. As a proxy for all other water-rich asteroids that have circled the sun in the last few billion years. It's a mammoth undertaking. We've looked at 1% of the sample so far, Connolly says, but it's sufficient to begin to test a wish list of hypotheses the team has about Benu's life. A key question: what went into making Benu's original or parent body? The clues reside within its pre-solar grains, crystals that condensed before the sun existed. Basically the building blocks of our solar system, says Perry, cosmochemist at the University of Arizona. So far, they've identified at least 2 broad categories of pre-solar grains. Plenty have the chemical signatures of the intermediate to low-mass stars that were in the later stages of their life. Such stars produce potential solar winds as they age, expelling much of their atmosphere into deep space to create clouds of gas and dust that can be recycled into a newborn star. Other grains hint at a more violent origin. We do have some pre-solar grains that appear to have compositions more consistent with what we find in supernovae, Perry says. Although this supports the long-standing suspicion that our solar system was seeded and enriched by the explosive deaths of a diverse range of thermonuclear furnaces. Not long after the sun emerged, the worlds began to coalesce around it under the gravity's influence, including Benu's unknown parent body. Venu may have existed as a mid-sized asteroid in a near-Earth orbit today, but teams suspect that eons ago, its water-loaded parent first took shape beyond the snow line. A diffuse thermal circumstellar boundary that determines where more volatile substances, including water, can exist as ice around a star. There is no agreement yet on how far Benu's proto-world formed. One hypothesis holds that it wasn't in the asteroid belt between Mars and Jupiter, but somewhere farther afield. Key to testing that notion will be the absence or presence of various ices and their residue within the sample. Water ice can exist close to the sun, including within the asteroid belt, whereas frozen carbon monoxide needs to be more distant, somewhere in the realm of Neptune to resist vaporization. The array of temperamental chemicals already found in the sample is consistent with an with an outer solar system origin, says Kelly Miller, a cosmochemist at the Southwest Research Institute. Intriguingly, the detection of a supercon of amina, an extremely volatile substance, was also announced at the conference. What's that? What the fuck is that? Yeah, but what is a What is this? Oh, ammonia. My mind is having a moment. My mind was having a moment. Ammonia. The supercon of ammonia, an extremely volatile substance, also announced at the conference. This could be associated with the asteroid's organic material. If it came from ammonia ice, then that would push Bennu's parent body out even further into the outer solar system. Connolly says, perhaps in or beyond the realm of the ice giant planets like Uranus and Neptune. Wherever Bennu's parent body formed, it was certainly not in stasis. The sample appeared to be packed with clays and other mineral assemblages that are clear signs of dynamic transformations, such as being saturated in liquid water or even having some of that water evaporated to leave behind salts. Bennu is dominated by materials that are altered by water, says Sarah Russell, a planetary scientist at London's Natural History Museum. Although this water wasn't scorching hot, it was certainly warm and may have evolved in composition over time, which suggests that multiple hydrothermal systems were driven by melting ice. Composition, that word! That ice melted, at least for a few million years, because the parent body had a toasty geologic heart heated by the decay of radioactive isotopes. Based on this, Bennu's precursor was at least 10 kilometers wide, perhaps larger. Back in February, the mission team announced the surprising presence of my mind is having a moment with reading stuff. Why is my mind deciding English? I'm not even able to do English. It's
included, so make sure to stay tuned.
Ed! When you say me how to say it.
We are looking at how to pronounce this name as well as how to say more interesting but often confusing words.
Yeah. Did you give me the word I want?
The channel if you enjoy learning. Phosphates.
Phosphates, that word! I don't know why! I knew what it was, but I just couldn't say it. Beneath the icy carapace of Saturn's moon in Eclipse, the geological tumultuous orb is a warm liquid water ocean that contains a range of ingredients essential to life, including phosphorus components. After finding phosphates within Bennu's sample, Osiris's principal investigator, Dante Loretta, speculated the asteroid may have been a fragment of an ancient ocean world. I'm not willing to go there yet because we haven't teased out enough of the petrology and photography of to put the story together. But Bennu is decorated with features that may be linked to surprising geologic activity. One of the types of rocks the spacecraft observed on Bennu, which looks like a cauliflower-like, is a lot like a melange, Colony explains. A smashed up, squashed together, mess of sediment-packed rock that is typically formed in subduction zones areas. I was about to say, I know that, subduction zones, igneous rocks. Found at Earth's continental margins and deep sea basins. Sediment packed. In other words, it had the first, igneous rocks are formed when magma or lava cools and crystallizes. And then when sedimentary is where it gets packed in there. Though Benu's precursory world having an Earth-like shape and tumbling of tectonic slabs is tantalizing, to say the least, but these rocks are chaotic and difficult to interpret. It doesn't mean that the parent body was tectonically active. Presently, most are envisioning not so much as a geologically hyperactive world, but a waterlogged rock with a dynamic youth. I like to think of it as a big mud ball. Okay, we go with that. That mud ball eventually ended up in the asteroid belt, perhaps after being yanked out of a more distant orbit by the gravitational pull of Jupiter. One working hypothesis is that after about 3 billion years, this parent body was destroyed by a catastrophic collision, liberating the shard we know as today as Bennu, which eventually made its way into near-Earth space. That inward migration speaks of a key chapter in the history of the solar system, the delivery of water and prebiotic organic material, carbon-based compounds used in biology, to rocky worlds. It's a long-standing question, where did Earth's water come from, says Richard Binzel, an asteroid expert at the Massachusetts Institute of Technology. For a long time we thought it came from comets because they're the most water-rich things we see. But in recent years, investigations of water ice on various comets has revealed its chemical fingerprints to be quite different from those for the water that fills the Earth's ocean. Conversely, the water found within most myriad soggy meteorites is far closer match to that of our planet's reservoirs. And what of Bennu? That grand reveal is some time away, but regardless of whether Bennu has Earth-like water, that perennial query won't be definitely answered. Earth's seas and oceans were probably procured from a variety of cosmic sources. It's also possible that the creation wasn't reliant on asteroids at all. Rather, Earth's oceans may have been imprisoned within the planet as it formed, before escaping to the surface via ancient volcanism. Then there are the organic components. Biology started off life as chemistry, Preston says. Even in the exceedingly unlikely event that the OSIRIS-REx samples harbors fossilized alien microorganisms, Bennu won't provide any concrete answers as to how life got started on the Earth. But life couldn't exist at all without a suite of carbon-bearing components such as amino acids. One idea is that these formed in the spaces between the stars before asteroids like Bennu brought these ingredients to Earth. Goodness, we know that asteroids can deliver these things to the Earth, but the key step is, how did they become life? We need to know that inventory to be able to answer that. Already the team has identified a long list of organic molecules, including a suite of amino acids present in the sample. They even found uracil and thymine. Uracil being one of the 4 nucleotides based in RNA, and substituted by thymine within DNA. Some of these vital to life substances have also have primitive inceptions. Bennu contains organic material that form in the interstellar medium, and Nigel? Niguin? A planetary scientist at NASA. I'm so sorry because slaughtering these people's name. Not all astrobiologists are fixated on amino acids. I might be a bit of a heretic. Good way to start out, Cole Mathis. Astrobiologist at Arizona State University, but he hasn't especially been interested in the abundance of organic material in Bennu. It's not hard to make amino acids. If you combine nitrogen, carbon, and oxygen, he says, these things are more or less unavoidable. Okay. Also, I would say that there's a typo and I shouldn't be saying much as I've been slaughtering these names, but that parentheses should actually be not parentheses. Quotation should be here. I mean, right over here beside he, not halfway through his statement. Shut up. I have no right to say anything on these lines. I don't speak good English anyways, and I don't read good English either. I don't write good English. Asteroids may have delivered them to Earth, but much like the planet's water, these compounds could have easily formed on Earth without requiring a Bennu-like delivery. Mathis wants to use Bennu to explore the boundary between chemistry and biology. There are some molecules that are so complex that only life could have made them, he says, offering vitamin B12 as an example. He isn't expecting anyone to find anything like that in the sample, but he wants to find out which molecules can be made by both life and abiotic chemistry, which can only be made by life. Where should that transition be? Bennu, he hopes, will offer hints as to where this boundary lies, because the more baroque an component is, the trickier it is for chemistry alone to make it. Okay, if you're wondering what the baroque thing is, as an artist, I can say this. Baroque design is fucking complicated. It's solid, it's very, very thick, layered, and overdone in the sense of, I'm guessing Rococo and kind of the following, because the following art style that came after that, it being more light and then onto impressionism, well, kind of was a reactionary to it. But I think, as much as they make the joke in Beauty and the Beast about if it's not Baroque, don't fix it, they limited their Baroque designs in that, because I know it's an animation and all this other stuff, but some of those castles with Baroque designs are absolutely more ostentatious. Like, think of the dancing ballroom scene where, you know, they show the painting above the chandelier. That's Baroque. And some of the Baroque things are just very, very... Anyways, I'll stop being arty about it. But that's what he means by more Baroque organic compound is. The trickier it is for chemistry alone to make it. Mathis' inquiry is then not about the abundance, but the chemical convolution. What is the most complex individual molecules one can find in these materials? Answers to this question and many others are forthcoming. They are hidden within a small pouch of pristine asteroid material awaiting interrogation. These grains may have cost $1.2 billion to bring home, but they're effectively priceless because they can add context to that famous aphorism, "We're all stardust." Scientists are now beginning to find the exact nature, provenance, and of the star, the stuff that went into making everything we see. I think this is almost the end of... Alright! I think this is the end of, like, Space and Physicists, and this... I have this quote in the thing of... physicists have found a ghost! I mean, the ghost. I know it's a part of the title of this, I just figured it'd be an interesting title part. Physicists have found the ghost haunting the world's most famous particle accelerator. By the way, CERN's Proton Synchrotron will turn 50 in 2026, and as a resonant ghost. Using mathematics, physicists have measured and modeled how these resonant lines intersect, and modeling a 3D shape over time requires a 4D system of equations. Fun! In new research published in the Journal of Nature Physics, scientists at CERN have announced they have isolated a resonant ghost that affects how particles behave inside the super Proton Synchrotron. It's a 3D shape that shifts over time, meaning it's best measured in 4D. And the secret is the same reason you spill your coffee walking back to your desk or super bounce your friends off the trampoline. Okay, the SPS is a ring that is nearly 4 miles across, dating back to the 1970s. That sounds like ancient history, but SPS has remained vital at CERN. In 2019, it received a upgraded beam dump, which is like a runaway truck ramp for the high-powered beams inside SPS. So when researchers noticed the ghost in the machine, so to speak, they knew it was important to map and understand for future work. The ghost is caused by resonance. When the things have energy and mixed waves, those waves can interact with each other and create weird little loci. Loki? Loki? Locations. Okay. Loci. Excuse me. Oh, so it's locations. So they're, we're using the... We're not just using location. We're going all the way back. Loci. Where energy is amplified. When you walk with coffee, each step creates waves in the liquid that eventually meet each other and spill over. On the trampoline, one person jumps into another person's jump, and that resonates into a much higher jump. And in the SPS, spilling your harmonic coffee means losing essential protons, in which is known as beam degradation. Degradation. In accelerator physics, an understanding of resonances and nonlinear dynamics is crucial to avoiding the loss of beam particles, the scientists explain in the paper. And scientists, as much as I've been, up saying have this thing, scientists is spelled wrong right now. This. Love you! I have no right to be doing any grammar or I love you article person, because I have no right to be saying anything as much as I've been slaughtering things tonight. And how complicated it is grows as the problem in question gains more and more moving parts and more degrees of freedom. Each moving part, including the connectors, generates its own vibrations. Beam degradation is a huge problem, especially as the proton beams in question grow more and more energized and robust. And harmonics in complex systems affect any experiment where the particles interact inside a vessel, like a clear nuclear fusion research in tomahawks. The helicopters? Okay. Harmonic interference, therefore, is a huge problem in trying to reach productive nuclear fusion, creating dead spots where the stream of energy can lose vital heat energy. Inside the SPS, particles only have 2 degrees of freedom, which doesn't sound so complex. Like photons inside a fiber optic line, these SLS photons, also, it's SPS. Who? Not SLS. I love you, author, since you're trying to make this very understandable for us stupid people, but please. I bet you weren't paid enough. I'm saying that since journalists aren't paid enough, and you had so much work to do and didn't completely proofread. And I'm so sorry. And I shouldn't be ragging on you on this. Also, you trying to once again get this understood by laymen's is also. Boy, they travel. Okay, like photons inside a fiber optic line, these SPS photons are traveling in an overall path, but they can also bounce within that path because even a narrow beam or cable still has its thickness. SPS isn't a thick donut, but it's still a real life donut rather than a circle in geometry book illustration. And that bounce is distorted because of the human and reality factors. The SPS may be one of the premier facilities in the world, but everything in scientists has to be made with what we have. Magnetics that power these facilities are imperfect, and even tiny fluctuations in magnetism can cause a resonance. To quantify this, The researchers took measurements from around the SPS ring and used the data to build a math model called the I'm slaughtering this. Pointcaré. I'm just I feel like I should say this correctly. It's French. Of course it's French!
Bonjour, we are looking at how to pronounce the name of this French mathematician, theoretical physicist, engineer, and philosopher of science. We'll be looking at how to say more interesting and often confusing and related names of science from science.
By the way, who this is the voices.
For those.
Very smooth voice.
For reference, it is said as Poincaré.
Pointcaré. I will forget that. Absolutely. Pointcaré section. You'll stabilize one elephant. Yes, elephant. Element in this case, a fixed line in the researchers mentioned in their paper, and step through a system mapping all the intersections of other elements until you form an entire surface. The results are like an MRI, but for a dynamic system whose shape may change with each step, and in this case, with the addition of time as the fourth dimension. And since resonance is in a closed system like the SPS ends up repeating, the 4D surface study can loop like a well-made GIF. Fuck you for whoever says that it's some other way. I don't care. I'll use both ways just to piss you off. GIF. In their maths, teams found that the fixed lines could predict where particles would gather up. By the time to study the model model the phenomenon, they hoped to help researchers who develop strategies to dampen the effect of these fixed harmonic lines. The work could also help those constructing new particle accelerators work to avoid creating magnet ghosts in the first place, which could save a lot of money by keeping the beams and data more intact and deliver higher quality results with less work. I've already forgotten how to correctly say that name. Yeah. All right.